a pleasure to be here today. We're going to talk about detecting advanced threats using risk correlation and SIEM through McAfee's new correlation technology. So a little bit about Nitro Security first, and then we will get into the meat of our presentation. Nitro Security, which as everybody should know, was recently acquired by McAfee, provides real-time security and compliance. It provides integrated SIEM and log management with an unmatched speed and scale due to our advanced patented database technology. This is a proprietary database that we utilize, and it gives us speed and scale advantages over other SIEMs. We also provide unique database and application monitors as well, giving us the only content and context-aware SIEM. We have an advanced three-way correlation engine that gives us the risk feature, historical correlation, and an advanced rules-based correlation. Nitro Security is also certified for defense and critical infrastructure. We are EAL3 certified for common criteria, and we are FIPS 140-2 validated as well. Nitro Security has been and continues to experience rapid growth. We've had 70% average annual sales growth over the last 3 years. We have over 600 enterprise and government customers, and we are now a part of McAfee, acquired as of November 30th, 2011. So a little bit about the products that we offer at Nitro Security. NitroView is our umbrella term, and it's our single pane of glass user interface as well. This is also somewhat unique. There's a single interface, whether you're looking at log data, whether you're looking at historical data, whether you need to look at your compliant log store to do all of your policy management, your correlation, your reporting. It gives you all of the visibility into every single one of the technologies that we offer. We then have kind of two tiers of products that we offer, solutions we offer. The first tier is led by our NitroView ESM. This is a traditional SIEM tier that we offer. NitroView ESM, this gives us our unified visibility, correlation and analysis of the normalized data that we collect, compliance and reporting. We have views, reports centered around such things as PCI, HIPAA, Sarbanes-Oxley. We also have, and the policy management done from this as well. The ESM runs the Nitro EDB, the embedded database that we call it. We're not reliant on an Oracle database, a SQL Server database, or anything else. We also have NitroView Elm in this tier. This is our compliant log storage for log management to meet a lot of compliance needs, to store the raw logs for forensics, exactly the way the devices sent those logs. The one thing that isn't shown on the slide but absolutely necessary for SIEM is our NitroView receivers. Receivers are also appliances or VMware based, and they give us the ability to collect third-party log data, whether it's syslog data being pushed to us or whether we are reaching out from the receiver, querying databases perhaps, or integrating with APIs such as Checkpoint's OPSEC. The receivers feed data to both the ESM and into the Elm. We rate our appliances on events per second. They're performance rated. They're not licensed per events per second. So receivers range anywhere from the physical appliances from about 5,000 to 20,000 events per second. But by rating instead of licensing them, what we do is if you have a receiver that can collect 20,000 events per second, occasionally you may get spikes in traffic if you're running right up against that limit especially, and you may spike to 23,000 events per second. During this spike, we won't drop the events. We will actually parse, normalize these events, still send them to the ESM, and continue to queue up the events rather than drop these events. ESMs are rated anywhere from 50,000 events per second up to 300,000 events per second, and storage available on each one of these. The ESMs ranges from about 4.5 terabytes to about 7 terabytes on the larger appliances, with the option to also extend the storage through some direct attached storage devices up to 50 terabytes. So we have significant amount of storage for the normalized data, allowing you to keep a year or more's worth of live data to look at, to review, to run your reports, to use for correlation, etc. The Elms, they're the same for the storage. They contain from about 4 to 7 terabytes of storage, and they can also interface with external storage mechanisms such as SANs, such as CIFS or NFS storage. The next layer that we have, this is really where we start to look at, with the first two appliances, looking at content versus just log messages. The Nitro ADM is our application data monitor. This basically decodes layer 7 traffic. You can almost think of it as an IDS running at layer 7. It gives us full metadata collection for the application sessions. We're not just gathering flow data to understand what's going on in the application environment. We are actually session by session decoding these applications and looking and finding out that Bob has sent an email to Alice and Bob has included company secrets in a PDF attached to that email, possibly, and that might be matched against a data dictionary. Because this is also based on an IDS engine, we can also look for anomalies in the application layer, such as you now have an attachment to an email where it's a PDF, but it's actually an executable disguised as a PDF, and alert on those. The NitroView DBM works in much the same way as the ADM, except this is database activity monitoring here. So we're not going to the databases, turning on a high level of auditing or installing agents on the database. We're grabbing this traffic off of the wire. Both the ADMs and the DBMs work off of spans, port mirroring, or network taps, and we get log generation from this without having to impact the database in full session audit. So our user Bob logs into a database and logs out of a database, but we want to know what Bob is doing. What the DBM tells us is that Bob logged in. He ran 6 or 7 different queries. In some of these queries, he was looking at sensitive data tables that he didn't really have a need to be looking for. He was downloading, running large queries, and dumping this information out to flat files that he shouldn't be doing. And he's trying to delete a few things or maybe alter some records. We get a full session audit for that. The NitroView ACE is really going to be the focus of our presentation today. This is our advanced correlation engine. In addition to rules-based and advanced rules correlation that we offer with the ACE, we also offer risk-based and historical correlation. The major purpose of the presentation is going to be on risk-based correlation, which is basically using a unique customizable scoring mechanism to determine what assets are most at risk, or who are your riskiest users, and so on. And we'll go into this in quite a bit of detail. The historical correlation is a feature that allows us to take data that we've already collected and already exists inside of the ESM. So this data could be up to a year, maybe 18 months old, depending on how much storage you have. Taking that data and basically replaying it through existing and new correlation rules, risk-based correlation, and risk-based correlation managers that we have. So we can use this in a couple of different ways, and we'll talk about a couple of use cases for this as well. The NitroGuard IPS, this is where Nitro got our start with the IPS. Our founders, in addition to creating our proprietary database technology, also had an interest in security and were very instrumental in the development of Hogwash, one of the first inline IPS based on the Snort platform. And we commercialized this into an IDS appliance, an IDS IPS appliance, full firewall capabilities on this, flow collection as well. And with flow collection, it's also important to note that in that second tier with the ESM, the ELM, the receivers that we have that collect our data, they can also collect, normalize, and process flow data as well. So just a little bit of industry recognition that we've had. We are in the Leaders Quadrant in Gartner, ranked in the top 3 for critical capabilities. We have had significant movement from both left to right and from bottom to top over the past 3 years with Gartner. We've also recognition from InfoWorld, SC Magazine, the 451 Group, and others. You can find this information on our website at nitrosecurity.com. Well, so with the SIEM, traditionally what a SIEM does is right here: log aggregation, parsing, normalization, and correlation. We do it just a little bit differently though. Logs, sometimes just grabbing event logs doesn't necessarily give you enough data and doesn't put enough information at an analyst's fingertips to really be able to understand that event here. So when we look at the logs, for example, if we have port 263, we have a 263 after SSHD right here. What's the SSH service? Let's put some context around that, what this number means. The root user, who is he? Where is he actually coming from? What organization or business unit does he belong to? Roles and privileges and so on. IP addresses are great, but a lot of times the analysts don't know the full addressing scheme. An IPS may not, or an IP address may not mean anything to them. So we need to add a little bit to this, being able to do DNS queries to understand host names, which can be more descriptive and so on. So we take the log records, but we add context into those so you can get a deeper understanding of what these messages are, and then if information is available inside for correlation, for reports, and so on, including geolocation data. We do our geolocation instead of running a query against the database for a collected event and then running a geolocation query. We actually insert that into our normalized, into our parsed and normalized log record at the time of collection from every one of our appliances that collect and monitor data, the receivers for the log and event data, the application and database monitors for that type of network traffic, the IPS as well. So moving beyond logs and beyond the context that we add to logs, we really start looking towards our ADMs and our DBMs to really start to add some content and get some awareness. This is often something that is overlooked a lot of times inside of a SIEM. The application layer and the database layer. The database layer sometimes gets overlooked because of performance restrictions or on the databases, not necessarily wanting to turn on that level of auditing for fear of impacting the database and impacting your customers. The application layer, a lot of times we think that if we collect some flow data and we know who's talking and how they're talking across what ports, that this should be good enough. But that doesn't give us the content of that data set. It doesn't tell us who's using web protocols and how they're using those, what's contained inside of Word documents, PDFs, and so on that might be emailed around the network, what kind of anomalies we see. And all of this information that we collect gets fed into the ESM and used in our correlation rules, in our risk models, and everywhere. So we're moving beyond just what the traditional logs are. We've moved well beyond that. And correlation really becomes the key. So we take all of this different data that we've gathered, devices and applications, application content, user identity, location, vulnerability data, flow data, operating system events, time-based correlation, and we take this data and we correlate it together with a set of rules, correlation rules, to look and see if different events from different systems actually mean something when put together. Have I had 10 failed logins from a single source against a single system followed by a successful login, or 10 failed logins from multiple systems, and so on. So we put this information together to create alerts to help you gain an awareness of what's going on in your security environment and prioritizing those appropriately so you know which events you need to respond to immediately. So, but with rules-based correlation, there are some flaws in these rules. Rules-based correlation were really based on time frames and a series of events. They may happen in series or a group of events that happen in a certain time frame. So if we had an example rule where we're looking for 10 failed logins inside of a 10-minute window, and we want to be alerted any time that this happens, in that 10-minute time window, if that 10th login happens outside of that time window, our correlation rule isn't going to fire because our time window's expired. That 10th event is now going to be, since it's outside of our time window, the first failure for a new rule instance that triggers. So we've got to always play a little bit with the time windows. We've got to play a little bit with the number and the sequence of events to get there. Rules, by this nature, they're very static in nature. Whatever you have, it has to occur in so many minutes or hours or seconds. If it doesn't, the rule doesn't fire. They're very finite in nature. So is there another way to find out this information? Well, in our example of 10 failed logins that occur in 11 minutes versus 10 minutes for our correlation engine, We can run reports, we can look at raw events, we can filter those down, and we can do what we call visual correlation. So we're actually just going back to looking at our events. But visual correlation, this is why you bought a SIEM, to prevent this. This was the old approach years ago, and for companies that haven't necessarily adopted SIEM, it's the silo effect, where you have people looking at firewall logs and then looking at IPS logs and so on. And when they're looking at these, they have to communicate with each other, and it takes a long time to track down an event sometimes. Rules-based correlation, it is a valid approach, as long as you know what you're looking for. You know what the time window is, you know what the business impact is, so you can prioritize this and set the appropriate severities. So since rules have a valid use, but they're not perfect and they don't get me where I want, what kind of answer do we have? Well, with McAfee, we've taken a new approach to event correlation, and we call this risk-based correlation. It's kind of think of it as the difference between anomaly detection versus signature detection in the IPS arena. And when you combine the two, both rules and risk-based correlation, you get a more comprehensive approach to threat detection. Here. So what we call this is Nitro Risk, our risk score correlation engine. This is actually ruleless risk detection approach. We're not creating rules, we're creating parameters here. And they're based on things like asset information and context. Instead of just events directed towards an asset, what is that asset? How valuable is that asset to my business? Who's directing these events towards there? So it's Bob, but we don't really know who Bob is. We know his user ID is Bob. Well, maybe Bob's an administrator, maybe he's not, and that could make a difference. That could actually make a difference here. Vulnerability information. Let's take this information into account as well. Raise the severity of events and so on based on vulnerability data and what our servers or what our assets are vulnerable to. And let's observe this event activity over time. Let's not expire this in a 10 or a 15-minute window. And let's have the potential to track this possibly for days, weeks, and months, depending on how we want to actually set this up. So what we do here is we create alarms when thresholds are reached. We get these green, yellow, and red indicators for thermometers that we have that are actually risk thermometers, kind of taking the temperature, the risk temperature in your environment for those things that are most important to you. And this really affects the event severity based on the event's relevance to any of the observed risk. So we look at the graphic here. What we have is we think of these bubbles, and these glass bubbles are collecting a series of events. So these bubbles represent my correlation instance. And my risk correlation instance, as we'll see, could be something as simple as I just want risk correlation for every source IP I see external to my network. And I want to weight that appropriately with the severity of that event, or maybe it's something a little more complex where I want to look at the source geolocation of the event, combine that with the type of event, and combine that with a weighting system for the assets that this event is actually targeting or even trying to target, even if it's denied connections, but they're actually somehow trying to target some of my critical servers that I hope they would know the IP addresses for, but they found those. They're trying to target those. So what happens here is we gather a few events. So as we gather up a few events, we have a low-level risk threshold at a warning level. As we gather up a few events, these events get scored. And we don't have an alarm yet because we haven't hit our risk threshold. You kind of think of your risk threshold as your risk tolerance. Just like with any other business risk process, there's a certain amount of risk that you're willing to take. So you have to determine what that risk is, and that becomes the lowest score for that for our scoring mechanism. As we start to get more events, our score starts to increase, and we go from no alarm to having a minor alarm. Then eventually over time, as we see more and more events directed in the same fashion with the same pattern towards whatever it is we're looking at, we will generate a critical alert. So we have a critical risk alert. So now our analyst knows where to go look based on this critical risk alert, and he has all this information at his fingertips. So kind of a quick example, and then we'll get into the meat of the whole. System here with the risk scoring model. So if we look at our scoring model and the same as our image below, so a couple of different ways we can look at risk, and this is highly customizable. We could say that risk could be a function of the employee user ID times an impact factor plus maybe a project ID times an impact factor. So if they're accessing a certain project possibly, or maybe an application that a user is impacting here. So what we have in our first example, you get a higher risk score for certain clearance levels. Maybe this is a government agency, and we're going to track those people that have top secret clearances or certain project codes. And if they have a higher clearance, there's a higher risk associated with somebody having a higher clearance. If they're on certain high-level or classified projects, or company secret projects in the commercial space, having access to those projects with the specific project codes, again, there's higher risk associated with that. We're not necessarily saying our user is bad, but we're saying our user has the potential to be bad, and track that, and we mean risk. And the same with an HR system. Let's say that with the application and the user, let's say we're also going to grab a little more content or a little more context information on our user. So we're going to link into our HR system, a database that we query to gather some information and do a process that we call enriching the event before we present it. Before we present the event for correlation. So we'll look and we'll assign higher risk scores to specific users who've had poor evaluations. Maybe they're on vacation and they're logging in remotely from somewhere in the Himalayas possibly, or maybe they recently resigned, or they recently resigned and turned in their 2-week notice, but because of the critical nature of their position, we need them to continue for the 2 weeks. We can't show them the door. So we want to track what they're doing and look at what their risk is with this. So what we do is we quantify this risk continually, and here's an example. So the Nitro risk configuration is a scoring mechanism that I set up and work with here. I'm going to assign importance to any indexed value inside of my log fields, and inside of my event field, and I can base this indexed value on virtually everything that I want, anything that I want here. I can do my example of source geolocation and score that source IP field with a score of 100, which is the top score that we have for a specific risk field. If it's coming from Antarctica, say, I can score that at 100 because I don't do business in Antarctica. I should not have any penguins from Antarctica actually trying to log into my servers. Or I assign it to the users based on the role that that user has, or I assign a static value for certain URLs, or maybe I'm pulling this from a watch list and integrating like McAfee's GTI threat feed into this, and if I see values that exist on that watch list, I'm going to score these events with an appropriate score. So we get an event. This event occurs. It has a risk value of 10. The target asset of that event has a risk value of 20. Then we see another series of low severity events and so on. And we end up getting to a score here. We end up coming to here, and we get to a score that puts us right around 50, 60, 75, about 80 right here. We're at about 80 to 90. And then we have step 7 here. This becomes important, where the risk score naturally degrades over time. What this really means is whatever that score is, if my score gets to 1,000, we could liken that to a correlation rule. And if we liken it to a correlation rule, when we don't see any events and our score is at 1,000, in a correlation rule, that means our time window is expired. But we want this to be different. We want to be able to track this over longer periods of time. So instead of actually saying, okay, we haven't seen any events in 10 minutes, let's go ahead and just start a new risk instance here, or a new risk model here. Let's degrade this score. And let's say we set up a factor of 15% or 20% here. And so if we don't see any events in 10 minutes that match my risk model that I've created, then let's drop that score from 1,000, and let's drop that score down to 850, say. And then the next 10 minutes or the next 10 hours, drop it down by another 10 or 15%. So the scores kind of ebb and flow. Scores will continue to increase, but I don't see events. The scores will start to decrease. So I can really get an idea of where this impact actually heads. But then that score degrades, but then all of a sudden what's great about this is that score degrades. Say I was at a major alert before, the 3rd level below in our bubble. We're going to drop back down into that space between minor and major when we decay, but now we start seeing more events, and maybe it's a couple of hours later, but I've got a whole lot less to cover to go from this area, this gray area between minor and major, until this becomes a critical event, versus starting all over at 0 from the bottom. So I really am looking at that impact here and really watching those scores go up and down here. So it's a little bit of an overview here. Traditionally, we're kind of all used to seeing risk is equal to threat times asset times vulnerability. And that's a valid approach for certain things that I'm going to do, but when I'm pulling in live log event data, it's not necessarily a perfect approach here. So what we've done is we've kind of tweaked this a little bit, and what we're really saying is risk is kind of a function of the threat and the asset. So we define it as a function of this, and the threat and the asset could really be anything. The threat doesn't necessarily mean the signature that I pick up from my IPS. The threat could be my admin users. The assets could be the servers or the applications that they're trying to log into. I can quantify these things in any way that I want here. So how do we do this? Well, we need to assign scores to events based on the data contained within that event. If we think of a single event that our SIEM has gathered and it's parsed and it's normalized, well, what can we gather? How can we score different fields in this event? Well, attack location. We can leverage geolocation data, which we provide. Who's directing the attack? What is the source IP? Is the source IP on a bad actor list? Is the source IP, if I've integrated this with McAfee's GTI, is the source IP listed in there? If it is, it's going to have a much higher risk score. What's being exploited? The assets, the applications, the destination IPs, and so on. So what's actually being possibly attacked here? How are these assets actually being attacked? Looking at the signature or the normalized event taxonomy. By the signature, we might look at a firewall that might drop and another firewall denies a connection. With the normalized event taxonomy, we might look at this and say that both of those, regardless of whether it's a drop or whether it's a deny or whether it's a numeric signature, they all equate to a denied connection. So everything gets normalized into a taxonomy. So I can score the signature or I can score that taxonomy. Or something such as we mentioned, an IP inside of a watch list here. So we take all this data and instead of filtering it into a traditional rules-based correlation, let's filter this into a risk model and let's see what actually happens here. Well, in addition to some of the static information, let's leverage something called data enrichments that we have. This is often referred to out in the world as referential data. Referential data is basically it's data that's not contained in that event. So it's not one of my fields in the event, but it can add to the value and the accuracy of the risk correlation. Some example sources for referential data, it's my LDAP servers or my AD servers. Looking at this kind of information, I get a user ID of B. Smith. That doesn't tell me a lot if I'm an analyst that B. Smith did this. But if I get something, let's query that source and let's tag him as being an administrator because he belongs to that group. Maybe I've got my own internal database that I want to leverage with some type of different data in there. HR database, as in our previous example, looking for employees who have recently resigned or employees that have been terminated and maybe their user IDs are still active on the network. So I want to know about this in real time, not just a report every 24 hours or every 7 days that I may or may not get around to looking for. If I'm managing SIEM for external customers, we can reference an SLA database possibly, or for internal customers if I have SLAs with different business divisions. So that can help me to prioritize the events. If somebody's got my platinum or diamond level SLA, I know I need to respond to their events faster than somebody that's got a silver level. Geolocation data, where is this coming from? Threat intelligence like McAfee GTI. So really when we leverage this data, let's take our example of users again one last time here. All users, we can assign them a default risk weight. We can say every source user I see gets a risk weight of 5, or I can sit here and put together a series of filters and statically say these are all my administrators. So now since these are all my administrators, I want to go ahead and build out a static list and assign them a weight of 25 because they're my administrators, carry a higher risk with their actions. That's a lot of work and people leaving and changing. Let's use some referential lookups to an LDAP source, assign everybody in my admin assign them that 25, and Let's make sure that this is recurring. This happens every day at maybe 3 in the morning, so I don't step on the toes of any of my Windows admins. Let's go out at 3 in the morning, grab a list of administrators, or grab all my user and group membership from my LDAP servers, and make sure that we continually update this, so it's not a static source, but something that's real and evolving every day. So then once we've started to put some referential data together, or some of these lookups and enrichment, you start defining some risk parameters. First and foremost, risk is never one size fits all. Every business is different. Everything that every enterprise does is different. What your risk is versus what somebody else's risk is versus what my risk is, it's never the same. You will never find two companies, even with the same technologies, that are competitors. You'll never find a risk assessment from each one of those that matches up and says this is where your IT risk exists, and it'll be exactly the same. So we've created something highly customizable here. So what we really do here is we pair fields together and assign values to those fields. So we leverage information we have, like we mentioned, to enrich this event, and we create a risk score correlation manager using one or more fields contained within these events. And an event can have fields applied to one or more risk managers. So I can create, if I'm pairing fields, I can create a risk manager with source IP and destination IP. And I could filter that down, and I want to look at traffic coming from outside my network and see what they're trying to connect to inside of my network. So only do this for external sources and internal destinations. But then I can use that source IP in another correlation manager where I'm looking at the source IP along with the user ID and the application that they're accessing. So I can apply a single field in an event to as many risk managers as I actually create here. So we pair these values together, things like user and destination. Source IP, destination port, but let's score the source IP based on geolocation data. So where are they coming from outside my network? What destination are they trying to get to? What port are they trying to access, to give me a little intelligence about their thinking of what applications or services I might have on that server. Maybe we'll pair a source user with a dynamic value in geolocation. Dynamic value could be enriching a field. This person resigned a week ago, so every time an event comes into my SIEM with this user ID, we're going to tag a custom field in that event and say resigned user. So this could be Bob, resigned employee, and geolocation. Where's he logging in from? If he's at work doing his job, great. But if he resigned and he's working from home, he's coming from outside my environment, I might be a little concerned about that here. Determine weights for these values. A weight, nothing more than a score for the content of the event field. Customize this any which way I want to, between 0 and 100 for every one of these fields. Now determine the risk impact for these values. So it's how much consideration as a percentage that we're going to give to each value we're using in this risk correlation. So if we want to define a risk factor containing n values, the total of the impacts will have to be 100%. So if I have 5 values, I could have 20, 20, 20, 20, and 20. If I have 2 values, I can go 60, 40. On our user destination, my user is 60% of my impact, and my destination is 40% of my risk impact, meaning I'm worried a little more about the user than the application, or I flip that around, or I make it 50-50 here. So I have a very simple high-level example right here, user and destination here. So we're going to create a correlation for each unique user and destination here. So in my assessment of the risk here, if both values are equal in my mind, my risk impact is going to be 50% for the user, 50% for the destination. If I'm more concerned with the rogue user, I'm going to assign a risk impact of 65% to the user and 35% to the destination. Each unique pairing results in a new correlation manager score is created. So if Bob is logging into a server, his destination is 192.168.3.5, he's going to have his own unique score for that, for him, that server, and that set of activities, versus Alice logging into 192.168.3.5. So I'm tracking each user differently, and maybe tracking them differently with each asset that they're accessing or attempting to access possibly here. So what we do is we collect all this data. We collect all this event log data. We collect all this flow data. We collect all this application monitoring events and database events and IPS events and whatever it might be. And we route these to these correlation managers, which are one or more fields based on these fields. We use lookups to leverage our referential data to add some context to the content. So the content is Bob. The context is he's an admin. Each unique set of values has its own correlation manager. So as we just described before right here, by doing this with each unique instance, this dictates that Alice and Bob's activity involving the same destination is tracked differently as it is to differing destinations. Here. This is kind of a screenshot of an example right here of risk scoring in action here. So what this actually tells me, if you kind of key in and take a quick look at it, in this first window we've got a source user risk, and the bright red bar is for one of our users named Mel. And we've got a percentage value after that of 1,112.44%. What this tells me is that Mel is 1,112.44% above my critical risk tolerance for his activity. So Mel's on my list here. Well, simply by clicking on Mel right here, and which I would have done inside of my UI, look at this event summary that's bound to my risk distribution over here. So this is Mel's activity right here. He was doing a lot with our databases here. He used a lot of insert statements, schema changes, creating and dropping tables, playing with our audit trail, and so on. Get a risk distribution. When did these events occur so I can see, quick glance. These occurred Mel's a hard worker because Mel has a constant stream of events from midnight all the way up until 9 p.m. here. So Mel's working hard here. Maybe Mel's working after hours on a side project using my data. This is Mel's source IP. Where's he coming from? I could very easily leverage a little bit of data here. Look at this event. Look at his geolocation data. Look at the with the source IP here. Not only look at that, but look at where is he when he's logging in. This come through the VPN. And down here, this is a more in-depth summary of all of these events up in the upper right-hand corner. So why would Mel come in and stop auditing and then start creating tables and making schema changes? Detecting this kind of activity becomes very difficult with a correlation rule. Again, we can go back to the visual example, and I could look and see that Mel has a lot of user activity, so I can go focus in on him, but there's a significant amount of users right here. Right here, as we can see, that we've got a scroll bar. So how do I know which user to zero in on? Well, I'm 1,100% above that. I could have picked even a different user here, but I'm way above my risk tolerance, so I need to take a look at that. So what we provide to do this is NitroView ACE, our advanced correlation engine that we looked at before. It gives us real-time historical correlation, rule, and risk-based correlation as well, and gives us a platform for future correlations. Very scalable capabilities for large enterprises. You can scale them up, scale them out. Combines the rules-based correlation with this industry-unique Nitro risk-based correlation that we have. User-defined historical correlation. So when I want to do this historical correlation, I can, if I want to, I can grab all 11 billion events I have stored in my database, but I can also use a set of filters to very smartly say, I only want to see events from these devices or these class of devices from all of my firewalls, all of my Windows servers, and my IPS servers, because that's what I'm looking for historically here. And this is fully integrated into McAfee ESM right here, just like as we saw at that dashboard before. Architecture-wise, this is kind of what it looks like at a very high level. We've left off the database, the application monitors, the IPSs, and the Elm here. So we're just focusing on risk. We've got the receivers that are on the right-hand side here. They're gathering all of my third-party log data here, my third-party event data, my flow data. They're feeding that data into the ESM across an AES encrypted channel, and they're also feeding it down to ACE, where we're correlating this live data stream for real-time correlation or possibly replaying this. So these are appliances these are all appliance-based solutions that we offer to get you set up and get you started with risk. Works as few as one receiver, or as many as you need to scale out into your environment here. So a couple of quick things I'll mention. Everything that I've talked about risk-wise is customizable, not just the parameters that we're putting together for risk here, but my scores, my risk thresholds for my critical risk threshold versus my warning versus my warning, my majors, and my minors. The decay rates and the percentages. How long do I go without seeing events before I want the score to start to decrease, and what percentage is that decrease? This is all highly customizable. Every single portion of this is customizable for your environment right here. So we want to prioritize insider risk with weighted correlation and event enrichment for use case number 1 here. So we're going to score every single administrator that we have differently from a regular user here instead of just saying all my users have the same score. So in this example here, we've got Alice as an application administrator, Bob as a regular user. So we're going to leverage this data via that lookup to our Active Directory server. Alice, she's an administrator. Let's assign her a weight of 25, and this is all done in the background once this is set up. Bob, he's not an administrator. He gets a weight of 1. Now let's say both of them log into an application server with a weight of 10 here. So since my weights can be from 0 to 100, this probably isn't that critical of a server right here. So what happens when Bob logs into here, Bob's correlation manager, Bob's risk manager, looks like Bob 192.168.3.5. So we score him at 1 for his user ID times the risk impact, which we're going to say 50-50 in this, plus the weight of the server times that risk impact, and that gives us about 5.5 on our score here. We'll round that up to 6. Alice, she's an administrator. You can see she's doing the exact same thing. She's logged into the same server that Bob has, but her score is 17.5 or 18 here. Why? Because Alice is an administrator. When Alice logs into that server, because of the privileges that she has being an administrator, she can make changes on that server. There's a lot of different things that she can actually do that could directly impact that asset to my business. Bob can get into this server, and Bob can turn around and try to elevate his privileges, and hopefully he's unsuccessful. If he's successful, we track that as part of the risk model as well, and we weight successful privilege elevation attempts from non-administrators very high, for example. Now let's look at, let's say we want to look at some IP asset risk here instead. So let's leverage server assets never static in my environment here. New servers get added, old ones get deprecated or are supposed to get deprecated, but they may still exist out there. The same event directed towards 2 different servers carries more or less risk based on the value of that server to the organization. These range of risks. A laptop assigned to an employee. I think we've all had a laptop die on us. We've been out without one for a day or 2. We've worked on our personal laptops. Business still goes on. We don't feel like it, but business still continues. How about a server assigned to a PCI zone, database server in a PCI zone? I'm going to weight that a lot differently, a lot higher. Database that contains personally identifying information, we're going to weight that incredibly high, because if that information gets disclosed, we're dead in the water as a company. We all know a lot of companies that have failed because of disclosure of sensitive information that have never recovered from those type of breaches. So let's do a lookup to leverage some referential data. Weights for each server, let's assign those dynamically, including the role, the applications running on the server, the data contained within the application here. So if we do that, maybe we're leveraging an asset management database here, or maybe inside of our SIEM we're bringing in data from our vulnerability scanners, and we're using that to populate what we have inside of the McAfee SIEM, our asset database, and we're using the information from vulnerability scanners and from AD Discovery and so on to build out system tree and build out dynamic groups of servers based on the information that we get returned on leveraging other databases. So the system matches a PCI role. Let's assign that a weight of 50, but a laptop, assign that a weight of 5. So look at our user destination model with Alice and Bob. So in this case here, now Bob, he goes into a server here, and this server with the weight of 50 means Bob logged into our PCI server. So Bob's got 26.5, but Bob's not an administrator, but he's got a pretty good score for a single login here. Alice logging into her laptop, we picked that up with logs we're collecting, or just a server that's got a weight of 5 on here. Her score's only 15. She's an administrator. That still carries a high weight to it, but the asset that she's logging into doesn't carry as much weight with it, so we treat that risk just a little bit differently here. So we've looked at risk and we've talked about rules, so let's do some comparing and contrasting here. So risk versus rules, first of all. Rules work on linear factors, span of time for known values. 8 things happen in 10 minutes, followed by 3 more things in another 5 minutes, or the following 7 things happen. I've still got something finite there that I've got a finite set of things that needs to happen in a finite time pattern here. They're great for known attack vectors, known threats that follow a specific pattern, and I'm logging that specific data right there. They do a decent job for insider threat detection since the user and the assets are known. If you're specifically concerned about certain things, you know what those things are. You know who your users are. You can build rules to track them, logging into servers. You can build rules to notify you if certain things have happened. But that's a one and done kind of thing. The rule triggers and then the rule triggers again. Risk, dynamic, real time. This follows patterns of attacks over unknown and variable time frequencies. A lot of these low and slow attacks, or the APTs that everybody talks about now, and new and emerging threats, we don't know those patterns. We don't know what kind of time sequence they're going to happen in. We don't know when we don't know when the proverbial shoe is going to drop here. So with risk, I'm tracking scores based on content and context, not necessarily based on a certain pattern here. So we don't rely on known attack vectors, traffic patterns. We don't rely on a sequence of 5 things happen followed by these 3 things that has to happen. But this is not a battle. This is actually the best of both worlds here. Risk and rules together are going to give us a combined enterprise-aware approach. Rules, they're going to alert me very quickly for any type of known attacks. These rules are updated as new threats are discovered. We do that work in the background for you. We've got our Nitro Threat Analysis Center where we produce new correlation rules. We push out to you, just like your AV update services do, for example, correlation rules. Log formats change. We need to modify parsers and so on. New signatures, new normalization taxonomies. We do all this work behind the scenes and push this out to you on a daily basis here. Risk is going to allow us to leverage these data points to score events here. So we create a true picture of risk as defined by our security model. So whatever our security model is, we can apply risk to that, and we can look at these values here. Events are analyzed by both the rules engine and by Nitro Risk. If I've got both running in my environment, I don't say I want to send these events over to my rules-based correlation and these events over to Risk. Let's do both because they both serve a great purpose and they're both necessary inside of my environment. So kind of wraps up our presentation on Risk. This is not a new technology. This Risk is a field-proven technology that is in use at some of the Fortune 500 companies, and it's delivering great value for them in addition to the existing rules correlation that they have. At this time, we'll open this up for any questions that anyone may have.
Okay, thank you so much, Mike, and I'll be starting out with the questions as soon as we get a couple of them in. Okay, we got the first question. The correlation is done by receiver or ESM?
The correlation is done in one of 2 places. Correlation is done on the receiver if you're not leveraging ACE. If you are leveraging ACE, the correlation is going to be done on the ACE appliance itself. And if you have multiple receivers, you will designate one receiver as your correlation engine, and that will correlate data across your enterprise. Or alternatively, you can choose a receiver or subset of receivers, and I can say only correlate data collected by receiver X or receiver Y for leveraging things like managed service environments or global operations.
Okay, thank you. And then we've got some more coming in here right now. How does a company create the risk table, and how long can it take?
The risk table that we create, it's something that we have a few things default out of the box that give you a little visibility into source, destination, and user activity. And we work with the customer during our implementation to both create some meaningful risk managers for them and also to educate them on creating their own risk managers as well. The tables, the risk scoring is done in real time as the events come in. So as soon as we put an ACE in place and turn on a few correlation models, the risk scoring begins immediately. Populating the tables for the scoring using the referential data, that's entirely up to the user. They can query the data as often as they want to from a database or an AD server, or as infrequently as they want to. It's all time-based, so everything, again, highly customizable for this. And
Okay, thank you. And then we have the next one. We have a lot of questions coming in. I'm sorry, I don't think we'll get to all of them, but we'll do our best. How do you determine if the user has appropriate access before you use that access as part of your risk correlation?
This would be something that would be part of, possibly part of an internal process, or we may have to filter some different things out here. We can determine what a user's access privileges are based on things like what his group membership actually is, and whether or not he's possibly if a user continues to fail login to an application or a server, we're going to treat that a little differently. If he's failing login, he doesn't have access to the server, whether it's he doesn't remember that he changed his password on Friday before he left for a weekend in Vegas, or if he doesn't have access to it, we're going to treat that a little differently than somebody that actually does have access to that. So a lot of it becomes looking at existing patterns, plus leveraging those referential data sources to gather as much information as we can about that user. We would know, for example, if HR maintains a database of terminated users, and we grab the last 30 days of that, we know that those users, since they've been terminated, do not have access. So if we see those users inside of our environment, that's a very high risk score and an almost immediate or an immediate critical alert that we would get if we see terminated users accessing systems or applications.
Okay, thank you. Now we have another one. On my server, there are multiple domain users logged on. In such a case, how do you determine who the source user is when logging in at IDS event, assuming you use the source IP to determine the source user?
We're going to use a source IP to determine the source user. So where that comes from, we're going to tie that back in, and we're going to look at anything that source user has done. We might leverage some sources such as we might leverage some DHCP data possibly to determine who had a lease on that IP address, for example, during that time frame. There's a lot of different ways that we can do it. It all again goes back to a flexible, customizable solution that we offer. So there's a few different ways that we can do that.
Okay, and then we have the next one. A customer needs a system for preserving audit trails on all their OS platforms as well as DBs. Can we convince them into Nitro with accent or added SIEM and ACE value? How do those how to choose the right box since audit trails are not EPS critical?
Right, whereas audit trails are not EPS critical necessarily, that data has to come into Nitro, into our receivers in some fashion. Now we've got a lot of different ways to get this data. Maybe we're getting it out of real-time logs, or maybe some of these audit trails are written into static log files or databases. But at the end of the day, even if we're reaching out to the box via to this application or to the server via, say, an SFTP connection, when we're pulling that data in, that still becomes calculated as part of our EPS calculation. So if we pull back 1,000 events in a 1-second period, that becomes 1,000 events a second right there. Now there are some ways to throttle that if we're pulling non-critical data like this and just trying to bring this data into the SIEM. So there's some ways that we can throttle that down. Sizing is always kind of a tricky thing. Sizing is always a little bit of a tricky thing with the SIEM. We have to really understand a little more about the environment, how they plan on using the data, and how real time they want it to be before we can provide those answers. Oftentimes we'll have things like this where we're grabbing audit data that's written to files, and we're not doing this very frequently. We're maybe doing this every night at 3 or 4 a.m. and pulling this data in. And during those times, we can also balance it out, because if we're also collecting firewall and IPS data and other server data, that's going to be the busiest in most environments during business hours. We do things like this during non-critical hours, where event rates tend to drop by 30, 40, even 60% sometimes during off hours. So it becomes a balancing act, and just sitting down and understanding the environment, how they plan to use the data, what they want to get out of it, and then sizing it accordingly.
Okay, thanks. And then we've got another one. Does events per second include net flows? How much storage is needed for 1 billion events?
For 1 billion events on the ESM, this can be stored in about 4.5 terabytes that exists on that ESM, and even a little bit less than that. One of the things that we do at the receiver level is aggregation. A lot of times it gets confused with deduplication. It's not really deduplication. What we do with aggregation is we look at events, and let's say firewalls tend to aggregate very heavily. You have an event that is the same. It's a source IP trying to connect to a destination IP, and it's constantly being dropped or it's constantly being accepted. So what we do is we aggregate that event together. So we send that event to the SIEM, and the first time we see it, then we start this aggregation window, and every time that same event occurs, what we do is we update one of the fields that we have that's an event count. So if that event happens 10 times, the event count says 10. So this is up on the ESM. So now our analyst is looking at one row in a table or one row in a display, but they know that the event happened 10 times. They also know the first time it happened. They know the last time that it happened. They know what that duration is. They know the number of events. That's over on the ESM. Now, events that we send to the ELM, we never aggregate those events. We never aggregate those events at all, because you have to maintain compliance, chain of custody, etc. You have to have every single raw log line. We can't sit here and say we had 1,000 of them that look the same. On the ELM for the compliant log store, we have to say here's all 1,000 of them, even though they look the same and only the timestamp is different. So by doing this aggregation on the ESM side, it gives us two things. First, that I mentioned, it gives us the ability to it makes it easier for our analyst to actually look when he's looking at a huge events that a huge list of events that he pulled back from a query. Now what he gets to see is he's not seeing 10,000 events, he's seeing a series of aggregated events, but he understands the impact of this. It's also reduced storage requirements on the ESM. One thing to take in mind, though, we also use this, so we use that event count number, for example. If I set up a correlation rule, or if I'm running this into a risk manager, every time that event count updates, that event gets applied to it. So if I'm running a report, I don't see one event and then I have to drill into the details. If I'm looking at a visual report, not a table, not a listing, not a table type report, if I'm looking at a bar graph or a pie chart or something, I see a full representation of those 10 events that happened.
Okay, thanks. And then we have another question. Has SIEM technology matured to initiate automated actions to protect an enterprise, the same as an IDS and IPS?
SIEM technology is moving very quickly to that direction. There are certain things that can be done inside of NitroView, for example. We can leverage things like auto discovery and basically go out and discover your entire mesh fabric, endpoints hanging off of that, endpoints hanging off of your routers and switches and so on. And discovering and leveraging this data, I can look at a source user coming in from a message, the IP address that he has, and then I can take advantage of some things. If this is a bad session, I can, inside of the ESM, I can move him into a quarantine VLAN, I can drop him off the switch port entirely, and so on. Right now, a lot of the automated actions that you see do such things as let you, in response to an event, response to a correlated alert or a risk score, run a script that takes a set of actions. And one of the things that we have at Nitro is just that capability. So if I get a certain event, I can run a script off of any host that I choose, and more importantly, to make sure that the script makes sense and does something, I can pass all of these different normalized or indexed fields as parameters, or any of them that I choose, into that script. So I can create a script that will automatically, in turn, leverage this data, so I can pass a source IP or a destination port possibly, and I could create my script to use NetSNMP to actually do an SNMP set on an SNMP addressable device and update a rule or something possibly. But SIEM is moving to the point of taking automated action and being able to launch countermeasures directly from the SIEM. I always want to walk a fine balancing line with automated actions. You want to make sure that there's you want to make sure that there's some proper workflow put in place and notifications that the actions are taken, or you want to have them available so the analyst can launch those with a click of a button. And over the next couple of release cycles for McAfee SIEM, you're going to see that we're going to be leading the way in the ability to take actions from a SIEM.
Okay, thanks for that one. And then we have another question. If the correlated events are purged or deleted on the ESM, taking into account both the ACE and the receivers do not store event data, what happens to the link of the data that gets stored in the ELM? How does the customer pull this information from ELM for forensic or compliance purposes?
Okay, let's look at this. First, how do we pull information from the ELM for forensics or compliance purposes? We have an ELM search engine that's available. So when you have an ELM in your environment, you simply utilize the ELM search function, and you let it know what you're looking for. And it's a fully indexed data inside of the ELM. It's going to grab those raw logs for you. And the great thing is, as your search is progressing, you can simply click on a few different things in a window. You can narrow down your time frame, you can narrow down device sources and so on, and get that search to exactly what you want. It's going to return all that raw log data. Then you simply export that raw log data into a flat file, into a CSV file, whatever it might be that's acceptable for your auditor here. So if correlated alerts get purged or deleted on the ESM, what happens to the link to that data that's stored inside of the ELM? A couple of different ways to look at that. First of all, with our ESM, the idea of purging events is somewhat, for the most part, kind of foreign to this SIEM here. Because of the aggregation and because of the massive storage that we have, we can store all this normalized data, including these correlated events, including the results of the risk correlation, for a long extended period of time. Plus, when a correlation rule or a risk or anything like that triggers, I treat this like any other event that I have, so I can feed that information into the ELM, so I can go back and do historical searches on the results of this information. If I get to the point though that my ESM storage becomes full, and let's say I've got the 50 terabyte DAS on there, and I've got 49.9 terabytes on there, and I've got to purge some events. We don't need to actually purge the event. What we'll do is we'll set up an archive, and we can, using an NFS, using a CIFS, whatever storage mechanism you have, we can tell our ESM, all right, archive the last 90 days worth of data over to this partition here. Now down the road, 3-4 years down the road, I may have 10, 15, 20 different archives. But if I want to search data in one of those archives, it becomes as simple as going and looking at my archive listing, saying make this archive here searchable. It's going to do a quick re-indexing on that data, and then I'm going to search through the ELM and be able to search through that archive data. So concept of purging and getting rid of the events forever is a little bit foreign to us.